up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with geometric sequences and series. In this video, we are going to take a look at finding terms of a geometric sequence. So if you haven't watched the previous video, the introduction to a geometric sequence, make sure you do so you understand the background knowledge that's going to be covered in this video. First, we're going to start with a formula, the nth term formula for a geometric sequence. Some of the concepts or the components of this formula may look familiar to that of an arithmetic sequence. So the a sub n here is going to stand for the nth term. And that's going to be equal to a sub 1, or the first term in the list, in the sequence, times r, which, as we said in the last video, is the common ratio, to the n minus 1 power, where n is the number of terms. So we can use this formula to find any term in a list that's going to be a geometric sequence. So let's jump right into an example problem. So in problem number 3, we want to find the 10th term of the sequence. So we're going to look for a sub 10. What we need to input or to substitute in first is the first term, 3. Then we need the common ratio. So we're going to have to do some work to find this common ratio. So remember, the common ratio can be found by taking any term, let's say the second term, -6, and dividing by the previous term, 3. And we want to confirm that this ratio is, again, going to be common. So we want to divide each of the given terms by the term that came before it. And if we do so, we're going to see that the common ratio is -2. So I can substitute in a -2 for r. Then my exponent is going to be the power of n minus 1, or 10 minus 1 in this case. Basically what this is doing is telling us that the common ratio common ratio -2 is going to be applied to 3 9 times. And in doing so, we find the 10th term is going to be equal to a -1536. So you can find this value if you wanted to. You could take -24 and continue to multiply by -2 until you get to 10 terms, and you would end up with this number. So it gives us a little bit of shortcut, and this is especially useful when the sequences are very long, if you're looking for the 50th or the 100th term. If you take a look at example number 4, it is very similar. So go ahead and pause the video and see if you can find the answer for problem number 4. Hopefully you got the chance to find an answer here for problem number 4. In this case, we're finding the 8th term. So again, you could find all of the terms up to 8, but in order to save us some time for longer sequences, we're going to go ahead and use the formula. So our first term here is 625. Each of the terms from one term to the next is actually divided by 5, or multiplied by 0.25. or multiplied by 1/2. All different ways to write the same common ratio. So what we would have here is 625 times 1/5, or 0.2, to the n minus 1, or 8 minus 1 power. So I'm going to go ahead and let the calculator do the simplification there. So 625 times 1/5 to the 8 minus 1, or the 7th power, would be 0.008, which is 1/125. So you could write this one, because this decimal is not rounded, it's an exact answer. You could write this as either a fraction or a decimal form. So we can use this formula to find any given term in a sequence. We can also use this formula for other values. So in problem number 5, we actually want to find the number of terms in the sequence. So the formula is still going to be the same. Where we substitute and what we solve for is going to be slightly different. We can actually substitute for a sub n. A sub n is going to be 1/64. It is the nth term, or the final term, in our list. A sub 1 is still 4, the initial term, the first term in the list, the sequence. The common ratio this time, we could find, if you were to go through the first few terms, the common ratio is 1/2. We're dividing by 2 or multiplying by 1/2 to get from each term to the next. Now in this case, we don't know what n is, so our task is going to be to solve for n. So the first thing that I might do here in order to solve is to divide both sides by 4. So if I have 1 over 64 and I divide that by 4, that's going to give me a quite long decimal, so I'm going to put that as a fraction, 1 over 256. And this would be equal to 1/2 to the n minus 1 power. Now I need to get this n minus 1 out of the exponent, and so we saw this in a previous unit. Exponential equations, their inverse are logarithms, and so I'm going to use a logarithm with the same base here. So log base 1/2 of 1 over 256 is equal to n minus 1. Then to isolate n and get it by itself, I can add 1 to both sides. So if you need a review of solving exponential equations, you can find that in previous videos. So my expression, and some of you can probably do this in your mind, but my expression would be the log base 1/2 of 1 over 26, 1 over 256 plus 1, which I can input into my calculator quickly here using the change of base formula. So log of 1 over 256 divided by log of 1 over 2, and then plus 1, and this is going to tell me that there are 9 terms in the sequence. So you could have found this out by starting at 4 and dividing by 2 over and over and over again until you get to 1 over 24, and it would take you 9 terms. But it's, again, good to be able to use this formula for much larger problems. Now in problem number 6, we want to find the common ratio and the first term of the sequence. So what we're given here is two points on the, or two terms in the sequence. So what I'm going to go ahead and do is convert these into fraction form. So if I convert these into fraction form, a sub 4 equals 3 over 40. And you could use the decimals of these if you would like to, but I'm just going to try to short the writing in a little bit. And 0.0097375 is 3 over 320. So what I can do here is, as we saw with arithmetic sequences, is I can create a system of equations. So if I take this information for these two different points and I input that into my formula, I'm going to create two different equations. So a sub 4, the fourth term would be 3 over 40. The first term I do not know. R, I do not know. But I do know this would be to the n minus 1 power, or if this is the fourth term, the 4 minus 1 power, which I will list as the third power. Now that creates an equation with two variables that I cannot solve, but if I create another equation with two variables, I can combine the two to solve. So my seventh term is 3 over 320. So 3 over 320 would be equal to a sub 1, again I don't know the first term, times r, I don't know the ratio, to the 7 minus 1 power, or to the sixth power. Now, I need to simplify this equation. I need to get to a single variable. And I can do that through a process of elimination. In this case, substitution would be useful, but this is set up for elimination by division. If I divide these two, I'm not going to subtract because my terms on the right side of the equation are not the same, but if I divide these two, the a sub 1's will eliminate each other. So what I would get here would be 3 over 40 divided by 3 over 320, and this answer would be 8. The a sub 1's again would divide out, and if I divide r to the third power over r to the sixth, I can combine those through division. Sorry, not division, but subtraction. This would be r to the negative 3 power, which is the same as 1 over r to the third. So I use my exponent rules to get r to the negative 3, which is the same again as 1 over r to the third power. Now I need to get the r cubed out of the denominator, so I'm going to multiply both sides by r cubed. So 8r cubed is equal to 1. Then I can divide by 8. R cubed is equal to 1 over 8. And then I can take the cubed root of both sides. The cube root of 1 is 1. The cube root of 8 is 2. So we see some old solving techniques here, but the common ratio is going to be 1. Now that I have this common ratio, I can substitute that into either of my two systems. I'm going to choose this top system, but I can substitute it into either of my two systems to solve for the first term. So a sub 1 in this case, we still don't know. But now I know that r is 1/2. So I can solve this as 1/2 to the third power. 1/2 to the third power simplifies to 1/8. So this is like 1/8 r. And to get rid of that 1/8, I can multiply both sides by 8. So I would have 3 over 40 times 8. I can do that in my calculator. And I would get that my first term here is either 0.6. A sub 1 is either listed as 0.6 or 3 over 5. So here we can see another use of the nth term formula. In this case, if I'm giving two terms in the sequence, I can create a system and solve a system to find both the common ratio and the first term. So here we have some applications and some examples of the nth term formula for a geometric sequence. Thank you guys for tuning in, and as always, I'll see you soon.